This is the 1.4 notes over inverse functions. To begin, we just want to review what additive inverse and multiplicative inverse is. Additive inverse is what do you add to a number to equal 0. A multiplicative inverse is what do you multiply times the number to get 1. So just a quick example, additive inverse is the opposite sign of the number. So if the number is 4, the additive inverse is -4. The multiplicative inverse is what do I multiply by to get 1. So the easiest way to do that is to start by writing it as a fraction, 4 divided by 1, and the additive multiplicative inverse is the flip of that, 1 divided by 4. The sign does not change. So on additive inverse, it's a plus negative a equals 0. So 5/7 becomes -5/7. And the multiplicative inverse becomes 7/5. Okay, so that's a couple of examples there. Our next part of it is where we're putting a function inside of another function. It's called a composite function. So we're going to put all of 9 minus 8 into wherever x is in the x squared. So x squared is the actual g of x function, and then 9x plus 8 gets put in where x was. And then we will simplify. So we'll do 9x plus 8 times 9x plus 8. And then 9 times 9 is 81, x squared. 9 times 7 is 72, x. 8 times 9 is 72x. And then 8 times 8 is 64. So the final answer is 81x squared plus 144x plus 64. Okay, and then for f of h, that means that all of h of x will be stuck into the x on the f of x. So 9 parentheses plus 8, that part is from the f of x. And then where the x was, now we're going to put 8 minus x divided by 9. And now we can simplify. And because there's a 9 over 1 and a 1 over 9 here, I can get rid of those. And that leaves x minus 8 plus 8. And then -8 plus 8 ends up being 0. So this equals x. Okay. So an inverse of a relationship will reverse the two, the x and y. So literally 4 becomes 4 negative 5 becomes -5 4. 3 2 becomes 2 3, and 0 5 becomes 5 0. So our example is we're going to first label our 3 points A, B, C. Point 1 is at, or point A is at negative or positive 1, negative 2. Part B is at 2, 1. And C is at 3, 4. So the inverse is A naught, B naught, C naught. We're going to just flip our symbols. So, or flip our x and y. So it becomes -2, positive 1, 1, 2, 4, 3. And so our new picture, our new spots are at -2, positive 1, 1, 2, and 4, 3. 4. So if we connect these dots, it makes somewhat of a curve. We connect these dots, it makes the same curve. And splitting those curves in half perfectly is y equals x. So if they're inverses, you should be able to draw y equals x, and they will reflect across it. So you can see this line is reflected, turned over, and becomes here. This part of the line is reflected and turns and becomes here. Okay, this section is more examples. So these are parts that you need to do yourself. And you want to discover, see if you can figure out what is the relationship between the relation and its inverse. So the rule is that we use f to the -1 of x, and then we call it a composite of the function and its inverse, and vice versa. This little O looking thing actually means the word of. Now the best way to write this, another way to write it is f of -1 of x, like that, which is the same thing as f of -1 of f of x. And either one of those, if they are inverses, should equal x. So other thing to note is that the -1 on the f of -1 is not an exponent. So we do not rewrite f of -1 of x as 1 over divided by f of x. It doesn't mean the same thing. It's not an exponent. It's not on your x. It's on the function. Okay, so they are showing an example of how you would find the inverse of the function. This is the function f of x equals 3x plus 6. We rewrite it with a y. So y equals 3x plus 6. And then we reverse our x and our y. We just switch their positions. And then we will rewrite the equation. We will solve for y, and that gives us x divided by 3 minus 2 equals y. That new y becomes the f of -1 of x. Okay, but we want to check to see if we are right, if we got the right inverse for 3x plus 6. So what we're going to do is do f of -1 of x. And what that means is everything that's in this -1 of x, this symbol right here, that's x divided by 3 minus 2, goes where the x was on the f of x. So we stick it right there. So we're going to do 3 times x over 3 minus 2, and then that's plus 6, because it replaces all of x. Now, because there's a minus sign between these two, x over 3 and 2, we cannot just eliminate that 3. We have to actually do distributive property, distribute it to each piece. So we do 3 times x divided by 3 plus 3 times -2 plus 6. And then we're going to simplify. Now that there's no plus sign inside the parentheses with it, we can divide out the 3. And then we can say, okay, that becomes x. And then 3 times -2 is -6 plus 6. Those cancel, and we get x, which is what we want. We do the same thing, opposite. So this time, everything that was in the f of x, this whole 3x plus 6, is put into the x here. So it's going to be, so this time is going to be 3x plus 6 is where the x was, divided by 3 minus 2. And remember, just like with distributing, you can put something into everything. Well, we can pull something out. 3 and 6 have a common factor of 3. We can pull it out. So 3x divided by 3 gives me x left over. 6 divided by 3 gives me 2 left over on the inside of the parentheses. Divide by 3 minus 2. And then now I can cancel my 3's. So that gives us x plus 2 minus 2, which cancels, and that equals x. And that is what we're looking for. Because both of our tests came out to a y answer of x, because both of them came out to an answer of x, that means that we have the correct function and its inverse function.